Hello guys, welcome back. I hope everything is going okay. We are going on to the next part of inverse functions. So we are going to look at what are called logarithms. Usually we'll just say logs because it's shorter and easier. These are the inverses of exponential functions. If you recall, we'll look at graphs of them in part 2. If you recall, an exponential function has its variable is in the exponent. So a log or logarithm is trying to take that variable out of the exponent. So these are related to each other. I know if I have y equals b to the x, so let's say some number to this power gives me y, that can be turned into a log like so. This will now be x equals the log. Now since this is the base here, b, that will also be the base of my log. So whatever the base of the exponent is, that's what the base of the log is. So it's saying, oh, log base b. If that was a 5, I'd be like, oh, log base 5. If this was a 10 here, log base 10. If it was a 20, log base 20. And I'll start thinking about powers of this number here. So log base b of y. So let's look at this with a very simple example. I could say 2 cubed is equal to 8. So 2 to the third power gives me 8. So with this also, when I go into this new form, the exponent is now the number inside the log. So log base 2 of my answer 8, well, that's going to be equal to 3. Because this is basically saying 2 to what power is equal to 8? Oh, 2 cubed is 8. So 3 is the answer to that log. Now some logs will be very easy like this. You'll be able to kind of put it together. Okay, 2 to what power gives me this? But there are many that will not be, and we'll see how to utilize the calculator to do that. So that's going back and forth between these two bases. We are going to do some rewriting, and I think I need to make some edits on our notes. The notes page might need a minor edit. I think I made a typo on that, but I'll do what is there. So I'll just leave a note for you guys. So example 1. The first example, I will edit your note page to say this, log base 5 of 125. That is the math I did. Yes, it is. Perfect. So, with this, what it's basically asking me is 5 to some unknown power is equal to 125. Well, if I look at it, 5 to the first, that's just 5. That's so good. 5 squared would be 125. Or sorry, not 125, just 25. 5 cubed is 125. So, here with this one we were able to kind of see it and put together. We are going to use the Desmos calculator. So I went and downloaded the Desmos Calculator app. The Desmos Graphic Calculator app is awesome and it is powerful. So I'm going to go into here and it will allow me to write in here, just type it in just like I wrote it, log 25 or log 5 of 125. So I'm going to go functions. If I go over to miscellaneous over here, we'll see log base A. That's the one I want because it will let me put a little subscript number down here like 5. And then inside here I can type 125. And as you see, all I did was typed it in and we get 3. So this is equal to 3. So it's all about the calculator. So this was example A. Let's now look at example B. Example B deals with a fraction, but for right now, we're just going to utilize the calculator and life is going to be easy here. So it says log base 2 of 1/8. So log base 2 of 1/8. Now this is going to give me a negative number. It's going to be -3 because 2 cubed is 8. But since it's 1/8, I want to flip that fraction upside down. Just doing a negative power will do that for me. What I'm going to do, again, inside that Desmos calculator is just type it in. So I'm going to go function and choose the log base A option. My base is 2. And then inside here to do a fraction, I'm just going to do 1 divided by 8. And make sure, yep, it's in the parentheses. And hey, it's -3, just like I said. Now, like I said, the math behind that one, hey, 2 cubed is 8. Since it's 1/8, if I make that exponent negative, it takes the reciprocal of that number. So that's why the answer here is -3. Now, with the work you're going to do, not all of them will be able to be something you can handle inside your head. And we are going to still see an example like that in example D. But these were just, hey, they're ready to calculate. Let's just calculate them. Now we're going to look at 2 we need to rewrite in order to calculate. So the first one of those is going to say, this is example C in your notes, 3 is equal to log base 7 of x. Now, since the x is inside the log function, what I want to do is a rewrite like this. So in doing my rewrite here, that's going to say, hey, the base of the log is 7. So 7 is the base of my exponent. X is the answer. X is the number I want to know. The power 7 was 2 was 3. So it's going to just be 7 cubed is equal to x. Well, let's take the time in our calculator to see what 7 cubed is. So that's 7 to the 3rd power. And we see right here, we get 343. So x is equal to 343. So for something like this, since the x is trapped inside the log, I want to rewrite it as an exponential. The next one we're going to see, the exponent is trapped inside the exponential, so we want to rewrite it as a log. So this is example D. So that says 5 to the x is equal to 382. Now this is one, we can't use the same sort of logic here because this isn't going to work out for us. Because if I do 5 to the 4th, that's 625. So honestly, I know my answer should be between 3 and 4 based off of that fact, and it should be considerably closer to 3. But what that answer is exactly, I'm going to have to use a calculator. So let's take a look here at rewriting this into my log form. Since this has 5, that needs to be the base of my log. So log base 5. Now, whatever the answer was to the exponential, that's what goes inside the logarithm itself. So I'm going to say log base 5 of 328. Now, like I said, this is not something that is going to be very easy to calculate. Give me 4 decimal places on these. These are very precise calculations. I want 4 decimal places on these. So, again, I go into functions. I go under miscellaneous, log base A. Now down here in the subscript area, I'm going to put 5 because that's what my base is. And over here in the parentheses, I said 328. 8. There we go. So I got 3.5994. I was a little bit off. I thought it might be a little closer to 3 than to 4. It's a little closer to just being in the middle. A little closer to 4 actually, but I wasn't able to do this in my head. I need to utilize a calculator for this. A while back, people might have been utilizing things like tables and all that. We're not going to bother to even learn about looking at reading these tables when we had this nice, easy-to-use technology in front of us. We are just going to utilize the calculator. So that is 3.5994. So give me 4 decimal places, please. 3.5994. And that's it. So, this is the first part of our logs notes. Tune in for the next part where we talk about the graph of logarithmic functions and compare that to exponential functions. But for right now, we're just looking at it as, hey, how can I relate my exponentials and my logarithms together? And how do I calculate those logarithms? Have a good day.